Welcome to this module where we will apply techniques for searching strings. In this module, we will learn how to check if strings start or end with specific characters, identify whether strings contain characters or substrings, locate the position of characters within strings, extract substrings from larger strings, and learn how to apply search techniques without causing additional string allocations. The business has identified that some rows of data exported from historical systems are malformed and contain characters which cannot be processed. We must identify such rows and skip them if they begin with malformed characters. In this demo, we will learn to use the StartsWith method of the string type to identify the malformed rows. To take advantage of the next string feature, we'll work with some source data which can sometimes contain malformed characters. We'll open the US sales data and view the file's contents. The first line includes an unusual character and no further data. Let's assume this resulted from errors in the original export process used by the legacy systems. Our current processing logic should detect that this row is invalid because it doesn't contain enough separators. But let's explicitly deal with such rows to avoid some of the processing overhead. We'll explore the actual data contained inside this file. I'll use a hex editor to open the file. By highlighting the first 3 bytes at the beginning of the file, we can observe the value. I happen to know that the character that we found at the start of the file requires 3 UTF-8 bytes to represent it. On the right-hand side of the hex editor, we can view the Unicode code point of the character U2610. Returning to Visual Studio, we'll navigate to and open the sales data processor file. We can include a check for the malformed rows at the start of processing each line. Our plan is to check whether the row we are processing starts with this unprocessable character. For such tasks, we can use the StartsWith method on a string instance. StartsWith has several overloads. One of the overloads allows us to determine whether a string instance starts with a specified character. Another allows us to determine if the beginning of a string instance matches a specified string. In this usage example, we check if the string identified as myString starts with an uppercase letter A character. The result here will be true because the first character matches. When using string-based matching, overloads exist which accept either a string comparison option or culture info. When providing a specific culture, we can also optionally ignore case during the comparison. We know the Unicode code point of the character that we wish to identify, and we can use a character literal as the argument for StartsWith. We'll use Unicode escaping to specify the code point 2610, which we identified with the hex editor. We'll do 3 things if the row starts with such a character. First, we'll add the row to our list of failed rows. Second, we will log a warning that we found a row starting with an invalid character. And finally, we'll instruct the execution to continue to the next iteration of the for each loop, skipping any further processing of this row. I'll add a breakpoint here inside the if block. We can now debug the application to see the effect of our changes. Once the US data begins to be processed, the breakpoint is hit because the first row in that file is invalid. If I continue to step through the execution, having dealt with the bad row, we continue on to the next row. This row is correctly formatted and doesn't start with the bad character, so our code continues to process that row. We've seen enough, so I'll stop debugging and make sure to remove this breakpoint that we no longer require. As well as checking whether a string starts with a specified character or string, we can perform the same check but at the end of the string. The endsWith method has these same overloads as StartsWith and checks the character or characters at the end of a string against the comparison value.